Hey, welcome back to another video on the channel. It's been a while, but I think we're finally back to at least slightly more regular uploads. I don't think I'm ever going to be able to have that schedule again, but we're getting there. For today's video, we're going to actually be doing a really unique one. We're going to entirely from scratch make our own animatronic with Arduino. I have a ton of stuff linked down below about what Arduino actually is, but essentially, unlike the normal way of making one yourself, which is just like a wiper motor, you'll be doing it essentially exactly like Spirit would, so you'll be making all the circuits, creating everything like that. I know this looks scary, but I'm gonna try my best to actually make it easy and followable for you, so stick around. I will put a timestamp right up there if you want to see what actually this is gonna do. But yeah, so the animatronic will be able to turn with some movement via a servo right here. It will have sound, and also it will have a light up eye or multiple light up eyes, whatever you want. I won't be talking very much in this video just because I find that generally for tutorials, talking through text is much more effective and understandable. So in the building part of this, you won't hear my voice at all, and in the code, you'll hear it a little bit. But yeah, let me know if you have any questions down in the comments below, and without further ado, let's get into it. so I'm just gonna get in here and talk for a second because kind of hard to convey what you need to do in code through text. So first of all, you're going to need to actually get this variable speed servo library here. So in order to do that, you go up first to the link in the description below, and you can download the .zip for the variable speed servo library. Then you're going to go into Sketch here, include library, add .zip library. Then you can find the .zip file that you just downloaded for that, click it, and then click open, but in my case I already have that library. So including it here is just kind of going to help us be able to use it in the code. So next up is our defining code here. This code obviously shows what pin our items are connected to. So in my case, as you can see right here, I've connected my LED to pin 8, my speaker to pin 4, and my sensor to pin 9. However, this you can totally change based on what you've connected it to. So for instance, if I had connected my sensor to 5, then I'd just change that to 5, obviously. So really easy to change. Then next up right here, we have the Boolean flag. Don't mess with this, but essentially this is what makes sure that our animatronic constantly goes for the right amount of time. Because otherwise, if the animatronic was going and the sensor was triggered again, then it would go for longer than needed because the Arduino would detect that as another trigger and it would run this whole code again. Send these states right here, kind of similar to the Boolean flag. You'll kind of see what they do in a second here. Then these right here, these are the wait periods. I've set them to what I think are pretty good times. Or if you want to change it, the Arduino counts in milliseconds. So obviously these are for the servo, by the way. The periods for the actual LED and stuff we'll get to in a second. But this is in milliseconds, so this is 5 milliseconds for these. And then the movement period, which you will probably need to change, this is 30 seconds in milliseconds here. So that's just how long you want the servo to go for. Then right here we have the initial position. I've set it at 90 because if you were to attach the servo attachment and make that kind of a middle while it was at 0 degrees, then you wouldn't really be able to go right in the servo, which if you only need to go left, then that's totally fine. However, generally you want to set it at 90 so you can go, so you can have way more range of motion. So yeah, then right here, we come up to this setup code. So this defines things as either inputs or outputs. An input would be something like a button, and then an output would be something that the Arduino controls like a motor. So here I've set the sensor as an input pull-up because generally you don't want to set it as just an input because sometimes the Arduino can read false values for that. These serial prints you don't need to worry about. Those are just for me to make sure that the code works in the serial monitor. Then the servo.attach right here. This, for some reason, servos don't use defining code. So this is where you'll set what pin you've connected the servo to, which in my case is pin 6. Then right here, this code is just going to turn the LED off because otherwise, for some reason, with that BC547, the LED can start on, which can totally mess everything up. So you want that to start as off. Then the speaker is an output and the LED is an output. And then for those of you wondering what a setup code is, this is essentially just something that runs when the Arduino is turned on and it runs once. So then right here we have this timer. So this is where you're going to define how long the LED and the speaker stay on. And generally you're going to want that to match the movement period. So as you can see here, LED and speaker are both 30 seconds in milliseconds. However, you can change that. If you don't want it to match the movement period, you can totally do that. There's nothing stopping you. However, generally you want it to. So you can just change these to whatever time you want in milliseconds. Then we go into the loop code here. So this is the code that's going to run continuously. So this is just for defining code, or not defining code, defining times and stuff. So right here, if the sensor is low, which means it's activated, certain sensors go high when activated, so if yours isn't working, you can try changing that to high in all caps. However, generally it should be low, and the device is not on, so essentially the animatronic is not currently running. Then it will enable those timed outputs and turn these on, and then after the duration is expired, it will turn those back off. Then right here, if it's currently waiting for a trigger, then it will read that sensor value, and if it is low or activated, and the devices are on here, because in this case, it's like the tiniest blink of an eye before those LEDs are being activated, before the servo is activated. So in this case right here, we have the device on is true and the sensor is low, then it's going to move to 160 degrees. This isn't actually telling it to move to 160 degrees, but that's the current state. So then if you go down here, if the current state is moved to 160 degrees, then it's going to servo.right to 160, which is just moving the servo there. So this right here is the angle, this 160. Then this right here is the actual speed that it's going at. This you can adjust. I believe it goes up to like 250 something. However, that's like rapid speed that could damage your servo. I set it at 10. It's a little bit less than like Uncle Charlie head speed just because I feel like that's kind of natural. However, again, you can totally adjust that to whatever you want. Then it's going to go down here, and the state is now moved to 60 degrees, so it's going to move it to 60 degrees at speed 10, and then it's finally going to move it back to 90 degrees here at speed 10, which is whatever your middle is, obviously, if you want to change that 90 degrees. And obviously, you can change this 60 and 160 based on what you need. So now the device is on. So then right here, we just have this right here, which is just, all this is just kind of making sure that the movement is properly checked and timed properly and everything like that. You don't really need to worry about any of that. So yeah, that is pretty much it for the code. I've left this in a GitHub file down below. And essentially, in order to download that, you just click the link, and then if you're on a desktop, there will be a little green code button, and then you can just click that, and then click download zip. So yeah, now I will actually wire everything up. Oh, and then in order to upload, actually, forgot to say that, you can literally just plug your Arduino into your computer. Make sure, if we go into port right here, which my Arduino isn't currently plugged in, but if you've done everything right, there should be a port. In my case, it's COM11, and then it should say Arduino Uno in parentheses, and yours will probably be COM11 too. So make sure that the right port is selected, but it should do that automatically. Then you can just click upload, and my Arduino is not plugged in here, so it's going to say an error occurred while uploading the sketch, but for you it should say done uploading. So yeah, then you can just plug in that adapter for the servo, activate the sensor, and if you've done everything right, you should have an animatronic. So yeah, I will go activate it and show you guys how it works. Alright, so ignore the bad angle here. But essentially, as you can tell, things are very messy. If I had extended the LED with some wire, and obviously this is all for you, gonna be in an animatronic, so you won't be able to see it. You can also have a shorter wire. You can get that, I just didn't have that on hand. So this is pretty much done, except this right here comes with SD card, but it's a really low value one, or really low, like gigabytes, and I did not have one that low, and it only works with about that much. So it's not going to be able to play sound, but you'll still be able to see that turn on and stuff, and I'll point that out for you. Obviously, you'll have a different sensor here than I do. I'll just activate it for you and show you how it works. I have it, the servo power plugged in as well as the Arduino plugged in via the USB, but you could power it with the adapter port too. Alright, so yeah, here we go. You see that LED came on. The LED on that thing came on, showing that it's actually turned on. I didn't even bother to have the speaker connected. And then this right here, as you can see, is moving. I'll activate it a couple more times just to show you that it's not gonna have false triggers. And then obviously you can adjust these angles. And boom, yeah, that's pretty much it. Here, I will activate her again one more time for you, but you can see LED. And if you're using a DF Player Mini, you won't have that click sound, but I'm not really going to talk too much about that in this video. So yeah, that's pretty much it. If you have any questions or concerns, let me know down in the comments below. Or if YouTube decides to be YouTube and turn off the comments, then I will put my Instagram up there and you can just DM me questions you may have. But yeah, that's pretty much it. Thank you all so much for watching. Remember, everything is down in the description below. So the code, the library, the links to parts and everything like that, links to tutorials so you can learn a little bit more stuff about Arduino before you actually decide to do this. But yeah, that's pretty much it. So thank you all so much for watching, and bye.